Good morning, everyone. I hope everyone's had the requisite amount of caffeine and a good breakfast, and you're energized for this 9 a.m. session on day 3. In this session, we'll talk about how Vertex AI makes it easy to customize generative AI models. My name is Anand Iyer. I'm a group product manager in the Vertex AI team, focusing on a set of tools and services for generative AI. I will be joined on stage by my awesome colleague, May Hugh. May is actually the expert on the various tuning techniques, and she'll do a deeper dive on a subset of tuning techniques that we offer. And then we're very fortunate to have Lavanya Ramani join us on stage. Lavanya is Director of Engineering at Palo Alto Networks. And Palo Alto Networks is a customer and partner of Google Cloud. And Lavanya's team is actually a power user of Vertex AI. So she'll talk about her team's experience using Vertex AI to tune generative AI models. She'll talk about the positive aspects, and also she'll touch upon some of the rough edges that her team encountered. So yeah, with that, let's dive in. So I'm sure most, if not all of you, have used the consumer Gemini chatbot app, or perhaps ChatGPT. And these chatbots are really powerful, right? Out of the box. They can do multiple tasks amazingly well, and you've clearly not customized them on your data for your tasks, right? So you may be wondering, okay, then what's the deal about customization? So in this talk, we want to impress upon you the fact that for a lot of enterprise workloads where you have more focused tasks, you will very likely see better outcomes if you customize your generative AI models. And particularly in this talk, we'll talk about tuning. So first, let's do an overview of what we mean by customizing generative AI models. So in some sense, you start customizing when you provide the prompt, because in the input prompt, you're going to provide a lot of context. And often in the input prompt, you might provide a lot of examples called few-shot examples. At that point, you've started to customize the model for your application, on your use case, and so forth. But typically, when we say customization, the two key techniques that come to mind are grounding, retrieval augmented generation, and tuning. Grounding or retrieval augmented generation is where, as the end user prompt comes in, you dynamically look up relevant information from your domain-specific corpus, or you can even now ground on Google search, pull in that relevant information and pass it to the model. So that's how you're customizing it. You're customizing it with the relevant information. And on the other side, with tuning, this is traditional machine learning. When we say tuning, here we are talking about learning new parameters based on examples that you provide to learn these new parameters. Now, one question that actually often comes up is, which option should you use? And I just want to off the bat call out that these are not mutually exclusive. In fact, you might see best results if you use both of them in conjunction. And we actually have a lot of customers using both of these in conjunctions. I do want to call out these are not mutually exclusive. But that being said, let's look at a few rules of thumb for when you might want to pick one option versus the other. Now, let's start with grounding. Now, if what you're primarily trying to do is feed factual information. Facts and factual information is largely what you're trying to feed the model, then grounding is a good option, particularly if this factual information is also going to be changing at a regular cadence. Now, on the flip side, tuning is your better bet if what you're trying to do is teach the model some logic or semantic rules that are most appropriate for your application. Or perhaps you're trying to teach the model some syntax or jargon or lingo that's most relevant for your application. Or perhaps based on your use case, what you're trying to do is teach the model subjective preferences. Then in those cases, you want to go with tuning. Again, these are rules of thumb. There's no, it's not, the answer is not always very clear. It depends on the use case. But hopefully, this gives you guys a good idea of which option to pick when. So now let's dive into tuning, and let's look at the benefits of tuning. So with tuning, the primary benefit is you should, in most cases, get higher quality output. And of course, to get higher quality output, you do need to curate higher quality examples. Now, you'll get higher quality output because, as I mentioned in the previous slide, you can teach the model semantic rules or logic that are most relevant to your application. You can teach it lingo, jargon, syntax that are most relevant, and domain-specific syntax and jargon that are relevant to your application. Then there's also the aspect of safety, where a lot of enterprise applications, they're more focused, right? But you might still have an end user that gives garbage input, or maybe an adversarial end user. With tuning, what you can do is you can actually teach the model to focus better and ignore, or you can teach the model how to ignore garbage input or adversarial input. So that's the benefit of tuning: better, higher quality results, higher quality output. And you might also get cost savings. So how might you get cost savings? Now, let's start with prompts. Now, when you use prompt, you pass in the prompt, you are typically charged based on the number of tokens in the input prompt. Now, if you've done tuning, in many cases, you can reduce the size of the input prompt because you now have to pass in less context each time. You no longer have to pass in, or may not have to pass in few short examples, right? So that reduces the size of the prompt. So now, after you've done tuning, you can pass in smaller prompts, and you save costs in that way. Well, of course, perhaps the bigger thing is that you might find that with tuning, depending on your task, a smaller LLM or smaller generative AI model might actually perform as well as a significantly larger generative AI model for the tasks that you've tuned it for. So again, just by using a smaller generative AI model, you will save costs, and as a side benefit, you'll also see better latency. Now, of course, the cost equation has to be sort of worked out, because when you do tuning, there is a cost of running the tuning job, right? So you do have to balance the cost of running the tuning job with using the tuned model. But often, if it's a high QPS use case, you get some cost savings if you've done tuning upfront. All right. So now we're talking about tuning, right? We're talking about changing parameters of the model. So the question you might have is, OK, if you're updating parameters of the model at the end of the tuning job, am I getting a whole new checkpoint? Are you deploying this checkpoint separately? Or if it's not a separate checkpoint, is your data being used to tune the general model that's then being served to multiple customers? The answer is no in both cases. We use something called adapter tuning. That's the broader paradigm. What we do in adapter tuning is you keep the base generative AI model, the base LLM, frozen. So Google's Gemini models don't change per se. The Gemini models themselves are frozen. But when we run your tuning job, we learn a few additional parameters called adapter layers. And then when the result comes in, or rather query comes in, the query is served in a combination of the base model and these newly learned parameters. Now, we won't be able to go into all the details here. What I will call out is that our implementation is based on this technique called LoRa, L-O-R-A. And you can Google search for L-O-R-A and look it up. What I want to highlight is two things. I want to leave you with two things on this slide. First is your data and any parameters learned from your data stay in your Google Cloud tenant. So no one else has access to that. So no one else has access to parameters learned from your data, or results aren't served from parameters learned on your data. And then the other piece is we do not charge extra for using a tuned model. So whether you call our Gemini models directly or you run tuning and then you call the tuned endpoint, the cost is the same for you. Excuse me. So I want you to remember these two things. All right, so let me just provide a quick overview of 3 common ways of doing tuning, and then I'll pass things over to May to do a deeper dive. So the predominant way of doing tuning is, one common way of doing tuning is supervised tuning. And in supervised tuning, you're giving examples to the tuning job. And each example is the full input prompt, followed by the ideal or desired output of the model. And if the output of the model is multiple paragraphs, then you give the multiple paragraphs, the full output. And you give and the key thing here is you have to provide high-quality examples. And typically, with even hundreds of high-quality examples, you'll start to see good results. Then we have reinforcement learning with human feedback. And that, of course, is a fairly complicated topic by itself. But the key difference here is, here you're not giving examples of here's the input and here's the desired output. Instead, what you're giving the model with reinforcement learning is you're either giving it two outputs. So, of course, it sees the input and then two outputs. And you're telling it which output is the preferred output. So reinforcement learning with human feedback is useful for teaching the model subjective preferences. Or you give it an input and an output, and you tell it whether that output was good or bad. So here you're teaching it subjective preferences. And then the last form of tuning that is popular is distillation, where you're using a larger model as a teacher to teach a smaller model. And I'll hand things over to May to actually do a deep dive into supervised tuning as well as distillation. Thank you.
Thanks, Anand. Hello, everyone. My name is May. I'm a product manager on Vertex AI. I focus on the customization capability of our Gen AI model. So now let's deep dive into supervised tuning. Supervised tuning is a technique to customize model behavior with your own data. This process updates model weights to minimize the difference between model's prediction and the label provided in your tuning dataset. Supervised tuning is best suited for use cases where the output is rather easy to define. For example, categorization, summarization following certain styles, attribute extraction from long text, and train the model to output the prediction following certain format that's expected by your downstream application. So for example, an e-commerce company can use tuned Gemini to read the product description, extract important information, and output it into JSON line format, which can then be used to build your product catalog. And lastly, supervised fine-tuning is helpful to customize the model to specialize in your domain so that it can provide unique user experience for your end user. Now let's start with data. Machine learning is all about data. Gen AI model is no different. The quality of your tuned model highly depends on the quality of your data set. And here is a sample example of how the tuning data set should look like. It starts with an optional system prompt where it kind of gives the context of the conversation. Then it goes into a turn-based conversation between the user and the model. We support both single-turn conversation and multi-turn conversation. Then this example should end with model's reply, which is what we call the label that the model is trying to learn from. Some tips to help you prepare your tuning dataset. As mentioned by Anand, on Vertex AI, we use adapter tuning, which is a special class of tuning methods that can customize the model in a cost-efficient way. We freeze the base model, train a separate, much smaller adapter using your data. And because of the nature of this adapter tuning, we can usually observe a good performance boost with just a few hundred of examples. Of course, you can add in more examples to further boost the performance, but the number of epochs should be increased accordingly. Second, always adopt the best practice of prompt engineering. Provide detailed description of the task to be performed, clear instruction about how the output should be. The only difference is that you no longer need to provide few short examples in your prompt because you already tuned those examples into the model weights. And this is actually one of the benefits of tuning. At inference time, you can reduce the size of the prompt by removing those examples. Therefore, it saves you cost and improves the model latency at production. Lastly, your tuning dataset should mimic what you expect in production. Make sure the format, context, and distribution of your tuning dataset aligns with what you expect the model to handle in production. So after you prepare your tuning dataset, you can go ahead and submit a tuning job through Vertex AI, which we will demonstrate a bit later. But after the job is submitted, we provide real-time monitoring capability so that you can visualize how your tuning job is progressing, whether it's really learning. During this process, there are some common issues that you might encounter that can significantly impact the quality of your tuned model. The first common issue is overfitting. Overfitting happens when the model is learning too much from the training data set that it kind of lost its capability to generalize for new data. And you can easily spot it by looking at the performance graph. The first row of the performance graph is the training data performance metrics, where you can see the accuracy is increasing as your training progress. The loss decrease as your training progress. And these are all good signs. It means that the model is learning. But the second row is the metrics from the validation data set. And you can see that the accuracy start increasing, then decrease. And the loss start decreasing, then start increasing. So this is a typical sign of overfitting. And the way to fix it is to reduce the number of epochs to the point where for the validation data set, it reaches the minimum of the loss. Another common issue is that after all the hard work of preparing the tuning data set, submit a job, the model is just not learning. And you can spot it by looking at the graph where the accuracy and loss oscillates, but the overall trend is rather flat. And one typical reason causing this is usually your training data set. If you look a bit further, I know the number is very small, but the loss starts with a very high value. So if you see the loss starts with a number that's higher than 10, it means that the model is making prediction that's far, far away from the label. It's giving very wrong answers. And what can cause this is usually that the input prompt maybe exceeds the maximum context length that's acceptable by the model. And when that happens, we truncate the input prompt. And in other words, the model is making prediction based on incomplete prompt. That's why it's making a very wrong prediction. The way to fix this issue is really to go back to your training data set, make sure all the input prompts does not exceed the maximum context length, and make sure it follows the best practice we've introduced in the previous slides. Okay, so some final tips to help you get the best out of tuning. First, always start with the goal. What are you trying to achieve with tuning? How you want to measure success? Define evaluation approach and metrics at the beginning is very critical to the success. Different use cases may require different evaluation methods and metrics. At Vertex AI, our tuning service is deeply integrated with our evaluation service. You can run evaluation on a tuned model by calculating metrics-based evaluation or side-by-side evaluation. Side-by-side evaluation is an innovative approach introduced on Vertex AI where we use a large language model to compare the output between the tuned model and the base model so that you know whether the tuned model is performing better than the base model. Second, understand tuning is an iterative process. It's the same as any model training, where you need to spend time curating your data set, try out different hyperparameters before you can find the best config. At Vertex AI, all our tuning job is managed by Vertex Experiment so that you can visualize the performance metrics. You can easily compare different tuning jobs to find the best run. And lastly, after your tuned model is deployed to production, continuously monitoring the production traffic, what kind of queries are being sent to your model, all this can be valuable assets for you to use to continuously tune and improve the model performance. So with that, I will move on to the next customization technique, distillation. With Gen AI model become more and more helpful, and especially after tuning, you can usually achieve the quality bar that's required by your use case. And now your model is ready for production. And here you will realize the quality of the output is not the only factor. Cost and latency comes into play. And imagine if you are building a chatbot, no matter how perfect the answer the chatbot can give you, if it takes 10 seconds to respond, it's still going to be a very frustrating user experience. And this is where distillation can help. It reduces the cost and improve the latency at serving by reducing the model size. At Vertex AI, we adopted the latest distillation technique from our Google Cloud research. This is a published paper called Distilling Step by Step. You can easily find it from Google search. It has all the technical details. But at high level, how this works is that we use a powerful teacher model to generate the prediction and the rationale behind this prediction. So why the model is making such prediction. Then we use both the rationale and the prediction to train a much smaller student model to learn from the teacher. So with distillation, you can train a much smaller student model to perform the task with lower cost and better latency. And it can achieve performance on par with the teacher for tasks that it has been trained on. This is a performance benchmarking results that's included by the paper. The way to rate it is that the x-axis is the model size, and the y-axis is the accuracy. And as you can see, for a model with 540 billion parameter, it can achieve an accuracy of around 77% out of the box. But through distillation, you can achieve the same level of accuracy with a model of around like just 2 billion parameter. One last benefit of distillation is that it can overcome data constraints. We just talked about supervised fine-tuning, and we discussed how important a high-quality label data set is for the effectiveness of tuning. However, we also understand not every customer have this kind of high-quality data set. Curating a high-quality label data set takes time and effort. With distillation, instead of relying on human labelers to do the labeling, we will instead use the teacher model to do the label for you. In other words, all you need to provide is an unlabeled prompt data set, and we will handle the rest for you. So with that, I will move on to a quick demo to showcase how to use these two techniques in live. Okay. We will start with supervised tuning. After importing the necessary package, this is how you can submit a tuning job. And these are the only two required parameters for you to submit your first tuning job. The first one is the base model that you are trying to tune from, so Gemini Pro 002 in this case, and the training data set. You can optionally provide a validation data set. For advanced user, you can customize the number of epochs, learning rate multipliers, and things like that. But you really don't need to worry about this for your first tuning job because we already set the default value to be the number that can help you achieve the best performance based on our internal benchmarking results. So I will kickstart a tuning job. While the tuning job is running, you can see the performance metrics in real time. Here is a progress bar that shows like how much percentage the tuning is making progress. And then this is the performance metrics that's being updated in real time. This tuning job is going to take like an hour or so to finish running. So instead of waiting for it, I will just show a previously run successful tuning job. So this is the monitoring tab. The tuning is already finished. And here is the performance metrics for the training data set and the validation data set. We also have a data set tab that captures the profile of your tuning data set, like the number of messages, number of characters, some samples, so that you can scan through, and the data distribution. As for the detail tab, it kind of captures the configuration you put when you submit your tuning job. After the tuning job finish, you can easily run an inference on the tuned model. So now the tuned model is specialized to summarize dialogue. So here is a sample dialogue between two persons. So person two is visiting person one in hospital and giving her some flowers and magazines to keep her company. And now we will use the model to make a summary of this dialogue. So here is how you can make an inference from the tuned model. So tuned model.generate content, and this is the summary it just produced. So person one visits Miss Chi in hospital and brings flowers and magazine for her. So as you can see, the model is able to capture the summary very accurately. So after supervised fine-tuning, assuming you already achieved the quality bar of your model performance, now you want to take this model into production, and you want to reduce cost and latency when serving. Here is where you can do distillation. By doing distillation, you need to specify the student model, which is our Google's open source Gemini model. It's a 2 billion parameters, very small model. And the teacher model is our powerful Gemini Pro. Here you can kick off a distillation pipeline, and at the end of the pipeline, what's happening is that you will get a distilled Gemma being uploaded to your Vertex model registry, where you can then use Vertex prediction service to create an endpoint, deploy the model. And one thing I want to highlight here is that to serve a 2 billion Gemma model, all you need to provide is really like one L4 GPU. So if you have enough production traffic, this really makes much more economic sense for you, because now you don't need to pay the model per query. You just need to pay for the GPU price. So you are only paying for the infrastructure cost. After the model is deployed, I want to showcase the performance difference between a base Gemma out of the box versus the distilled Gemma. So here is the sample prompt. It's a question answering. So what attraction is sometimes so large that you need a map to find your way around? And give some answers, like multi-choice answers. And here is the base Gemma, like the Gemma out of the box. You can ask the base Gemma the question, and it will give you a wrong answer. It says the answer is backpack. A backpack is sometimes so large that it needs a map to find your way around, which doesn't really make sense. And, but if you ask the same question to the distilled Gemma that just learned from the teacher, you can see that it can give you the correct answer without any problems. So that's the power of distillation. With that, I will pass it to Lavanya to tell you more about how her success story with Vertex AI.
Good morning, everyone. Today, I'm going to be talking about how Vertex AI has enabled Palo Alto Networks' network security business, its applications, and its use cases. I'll also be connecting the dots based on what Anand and May mentioned, how fine-tuned models are part of our journey so far. Starting with a documentation chatbot. Picture this. If you are a customer and you're using Palo Alto Networks, you want to understand how do you get the basic configuration for your Prisma access, or want to debug or troubleshoot a broken IPsec tunnel between Prisma access and Prisma SD-WAN. Or you simply want to understand how the threat appearing on your Strata Cloud Manager dashboard means to you. Or simply you want to understand how to configure a policy, a security policy. Customer feeds all this information in a ticket and sends it over to the customer support engineer working in Palo Alto Networks. They look at the ticket, they try to gather the information inside, out, talking to subject matter expertise, Slack, trying to understand and discern from their own knowledge, put the information on the ticket, and send it back to the customer. This takes days for the customer to fix the problem, or based on the solution that has been suggested in the ticket, and costs millions of dollars to enterprises such as Palo Alto Networks. Working with Vertex AI, we are revolutionizing and completely transforming the support ecosystem. And documentation chatbot is a small part of it. It's a small step in the larger ecosystem that we are talking about. So what does the documentation chatbot do? It has 4 basic layers, starting with the query rephraser, which takes in the query of a customer and dwindles down to a short form text. So long form text becomes short form text by removing PII, unnecessary data, garbled text, angry words from customers, and then tries to make it short form for the enterprise search or Vertex AI search to take on. Vertex AI search produces top-end documents or top K documents based on the input that it has got. And this, after that, goes to a summarizer model, which runs on Gemini Pro and produces a compressed set of answers from these top-end documents. And finally, the answer coming from the final answer module, which is also running on Gemini Pro, and produces the right answer with the references link to the customer. All this takes now minutes and not days as it was taking earlier, and also improves our bottom line. One important point is the automated feedback engine. If you look at the automated feedback engine, today it runs on 2 side-by-side models, one that is coming out from the pipeline, and then one that we have the ground truth for. This comes up with evaluation scores. A good evaluation score means that we are good with automation, the answer is of high quality, and it's running fast at a good scalable number. Human feedback is added to verify accuracy today. Till we reach 100% accuracy, it's going to continue this way. And we are getting there. Human feedback in terms of thumbs up, thumbs down helps us in collecting metrics and make our models better as well. Let's talk about the uses of fine-tuning. Given that we have dwelled deep from what May presented, Bison 001 is part of our fine-tuned models today before we move to Gemini Pro. We got a 93% retrieval accuracy working with Bison fine-tuned model. Gecko, on the other hand, is also fine-tuned, and we got a Gecko percentage of 001. Now, you may wonder, where is Gecko being used? If you go back to the previous slide, we had 4 layers. Gecko works in parallel to enterprise search or Vertex AI search. Anytime an answer is coming out of Vertex AI search, we also feed it into Gecko and try to compare results between Gecko and the enterprise search. Why did we do this? This is needed for certain cases of NG firewall or next-gen firewall used in Palo Alto Networks and certain upgrade cases that worked well for Gecko. We fine-tuned Gecko, and Gecko 001 is being used in our pipelines, and we will be soon moving to Gecko 003. On Gecko 001, we got a 25% relative gain, and we got on the short form queries, and about 140% relative gain on the longer form context. We are also working towards getting to fine-tune Gemini Pro whenever it is available. Right now it's not, but we hope so in the next few weeks that it will be available for us. We will be using that for the multimodality use cases, primarily, and also trying it for 1.5 Gemini Pro. We cannot wait to try 1.5 Gemini Pro. It's been giving some stellar performance with almost giving 0 hallucinations and 100% accuracy for some of the data sets that we have used so far. So how has our journey been with Vertex AI so far? If you look at the x-axis and the y-axis, x-axis talks about the time, and the y-axis talks about the model used and the overall accuracy. Looking at the models used, we were at 70% for a small data set of 295 just over a year ago, or just under a year ago. Working with fine-tuned models and constant prompting, we have gotten to the point where we are at 93% accuracy on a large data set like 3,000 plus queries and answers, and we are continuously increasing data set, continuously keeping also the overall accuracy at 93%. Thanks to Gemini Pro 1.0, it has been a killer upgrade for us. What has worked so far in Vertex AI and what could be better? Starting with the first option of what has worked well, sheer number of choices. You name it, Vertex AI provides it. Gemini, Bison, Gecko, fine-tuned models. You're talking about Vertex AI search, Model Garden. These are all the abilities that Vertex AI provides on which Palo Alto Networks have been tried to mix and match and produce the answers. Secondly, Vertex AI search recall has improved dramatically in the last 6 months. We found the amount of effort gone in the Vertex AI search got us to a better recall percentage, due to which the answers coming out of our queries being answered in the documentation chatbot helped the customers and our internal customer support engineers. Gemini Pro is indeed a pro, an efficacy percent improvement of more than 5% that we got in the last 3 to 4 months once we moved to Gemini Pro, and we cannot wait to try Gemini Pro 1.5. Finally, the robust evaluation framework that has helped us overall in making sure that we continue to evaluate the data sets and make sure that our automation scripts continue to run at scale, and we control the regressions that we have. Thanks to Vertex AI for all this. In order to balance with what could have been working better with Vertex AI, When we moved from one model family to another model family, it was indeed a pain. We spent several weeks working with Vertex AI, and thanks to Vertex AI for working with Palo Alto Networks closely on this, moving from Bison to Gemini Pro has given us the results of 93% of efficacy. Other thing is we're also working with Vertex AI right now to work on Prompt Builder, and Palo Alto Networks will be one of the early field trial customers in that space. Second, the troubleshooting query results were sometimes inconsistent. Vertex AI search for the same intent, 2 different questions will produce 2 different answers. Now you would be like, why? The intent is the same. Working with Vertex AI in the last 6 months have gotten us over the hump, and we are now consistent at these numbers that you are seeing. The other thing that could have worked better is handling long-form queries. Some of the long-form queries would miss out the PII information and also miss out some of the complex queries information which is needed to produce a good answer. Again, working with Vertex AI has helped us in making sure the long-form queries gets handled correctly. Together, Palo Alto Networks and Vertex AI are revolutionizing the space, not just for our customers, but also for support, internal and external users, and our partners. The evolution of Vertex AI and Gen AI has just started, and the partnership continues to grow in the following years. We look forward to the continued partnership with Vertex AI for achieving greater technical innovation in this space.